All right, so for this question, number 7, we're being asked to graph position, the height, and then the instantaneous velocity. And we're going to just really kind of sketch this out. So for the diver, what their height is at each point, I'll do this in red over here. We'll say this is 2, 4, 6 meters. Okay, -2, -4, -6. Using the mouse, so I apologize, it's a little sloppy. But again, this is our height graph. So he starts at a height, is it a he? Yes. It starts at a height of 3. At 1.1, he reaches his apex of 4.5. So where's 4.5? About here at 1.1 seconds. This is an important point, so I'm going to kind of mark it on my axis here. At 2.45 seconds, so halfway between 2 and 3, he hits the surface of the water. That's his height here. And he then coasts down to a maximum depth of 3.5. So where's 3.5? Around here. Chills at the bottom for a second. So he's still at -3.5 for that moment in time until he coasts back up to the surface again. So s equals 0 at t equals 13. So first, make sure that we're on the same page in terms of his height at each point. What I'm going to do is sketch in this graph here, giving it a bit of an arc since he made a dive. Once he hits the surface of the water, I could see two things from here. One would be, if you just went simply because he said he coasted, that means it's a constant speed. It's probably not totally accurate. It's probably something more like this, where it's got a little bit of a bend to it. But either or, I'll make it a little bit, somewhat constant. He doesn't move at all when he's down here, so he stays at a constant height of -3.5, and then comes back up at a slightly constant speed. Or you could say, since he kicked off and then came back, maybe it's got a little hop here, where he shot back up a little quicker and then coasted to the top. So I could see something like that, but I'm going to leave it pretty simple because I just want to demonstrate the basic point here, which is that this curve of v is supposed to be his velocity at each moment t. Okay, so here what you're really looking for is good approximations for the velocity, which means the change, right? How do we measure average velocity? It's the change in s over the change in t, the physical interpretation. And this really means the slope of this graph at each point. Okay, so starting about here, you got to think about what's the slope. And so having a more accurate graph kind of helps. The slope at this point, I used the average rate of change formula to calculate the slope between here and here. And I said that's roughly about like 1.36. So that's where I'm starting here. So if this is the same, this is 246. 1.3 is somewhere around here. All right, is his like starting velocity. And then here, I noted this point at 1.1. This is special because this is a point where he kind of pauses, right? He's going up, hangs for an instant, and then comes back down. But at that instant, at t equals 1.1, he has 0 velocity because he's not going up or down, right? And that point, he starts to fall, and his slope is, his velocity can be approximated by this line. And if you, just took the average rate of change here and said that's a good enough job of approximating it, this slope is about -3.33. And you do that by using, again, the average rate of change formula, or the average velocity formula, between 1.1, 3.5, and 2.50. So, and I'm not gonna go through this because I really just want to focus on the sketching. From here to here, it's a relatively constant decrease. Oh, we didn't mark this over here. So this was -3.33 from here to here. So here's -2, -4, -6. Here we go. -3, say, from 1.1 to 2.45. In here, it was at negative 3.33. So that's like about here, right? Something like this. Stays relatively constant. And then he coasts to the bottom. What's the coasting to the bottom here? Well, here he's doing this a little bit slower than he was falling. And this slope over here, if you calculate, this is about negative 0.76. It's about negative 3/4, which is something like this. Right, here's 1, so here's 3/4. And that's relatively constant until t equals 7, where he hits the bottom and pauses. And so we know here his velocity will be 0. Again, the height of this curve is equal to the slope or the steepness of this curve. This is kind of like your speedometer. Can I write on this? All right, we'll just use the marker here. This is the speedometer. We'll be looking at this idea a lot later on. Or velocimeter, right? So the height of this curve tells you how fast this thing's changing. So it should be positive when it's increasing, negative when it's decreasing, 0 when it's not changing, like here, it's at 0. And then from here to here, again, relatively constant. It's increasing on this interval. That means my slope is positive. It means my velocity is positive. And it can be approximated by about 0.76 if you calculate the average rate of change between here and here. The 0.7, I think, just straight up. So, and that's about here. And that stays constant until he hits the surface again. What does this graph look like? Well, it looks something like this. It's probably, something continuous until he hits this point. And then from there, right, he's kind of coasting until he stops. So he has a speed like this until he stops. And if it's just a break for you here, that's kind of okay. Or if you connect them, that's fine. He pauses and then starts swimming upward at a relatively constant pace until he hits the surface. If your graph looks something like this, and this is terrible because I'm drawing it with my mouse, but this is all that I'm really looking for. If the numbers are off a little bit, that's okay. If it looks slightly different, that's okay. But what's important is that it's positive when he's jumping up or going up, which is happening here. Not letting me undo here. It is negative when he's going down. So for this portion, we see that this is all under 0. So that means it must be decreasing. And it is. He's decreasing from here to here. And then what happens? There's a pause. So that needs to be 0. Or there's that pause. And then it's increasing again. So that means the slope must be, the slope is positive, and so that means my graph over here must be above 0, must be positive. So I hope that helps clarify. Again, this does not have to be beautiful, obviously, but it does just need to represent those key points of increasing, 0, and decreasing.